today I'm going to make Dolly Parton's caramel turtle brownie mix. It's a little bit hard to say, but I can say bigger words at the same time. So I'm going to read. This is called Introduction to Organic Chemistry. And we'll start with 1.1, Structure of Atoms. You are already familiar with the fundamentals of the electronic structure of atoms from a previous study of chemistry. Briefly, an atom contains a nucleus made of neutrons and positively charged protons. Most of the mass of an atom is contained in its neutrons and protons. The nucleus is surrounded by a much larger extranuclear space containing positively charged electrons. The nucleus of an atom has a diameter of 10 to the negative 14 to 10 to the negative 15 meter. The extranuclear space where its electrons are found is a much larger area with a diameter of approximately 10 to the negative 10 to the negative 10 meter. Okay, now I'm going to prepare this groovy Pyrex. Okay, electrons do not move freely in the space around a nucleus, but are confined to regions of space called principal energy levels, or more simply, shells. Electron shells are identified by the numbers 1, 2, 3, and so on. Each shell can contain up to 2n to the 2 electrons, where n is the number of the shell. Thus, the first shell can contain 2 electrons, the second 8 electrons, the third 18 electrons, the fourth 32 electrons, and so on. Electrons in the first shell are nearest to the positively charged nucleus and are held most strongly to it. These electrons are said to be lowest in energy. Electrons in higher numbered shells are further from the positively charged nucleus and are held less strongly to it. These electrons are said to be of higher energy. Julie. Shells are further subdivided into subshells designed by the letters S, P, D, and F, and within these subshells, electrons are grouped in orbitals. An orbital represents the space where an electron spends 90 to 95% of its time. Each orbital can hold 2 electrons. The first shell contains a single orbital called a 1s orbital. The second shell contains 1s orbital and 3p orbitals. These orbitals are designated 2s, 2px, underscore x, 2p underscore y, and 2p to the underscore z. The third shell contains 1s, 3s orbital, 3 sp orbitals, and 5 3d orbitals. In this course, our focus is on compounds of carbon with hydrogen, oxygen, and nitrogen, all of which use only electrons in s and p orbitals for covalent bonding. Therefore, we are concerned only with s and p orbitals. This is funny. It says, flour is raw. Please cook fully before serving. This is dumb too. Alright, where are we? Shapes of atomic orbitals. All s orbitals have the shape of a sphere, with the center of the sphere at the nucleus. Of the various s orbitals, a 1s orbital is the smallest, a 2s orbital is a larger sphere, and a 3s is an even larger sphere. A p orbital consists of two lobes arranged in a straight line with the nucleus at the center. A given shell contains a set of 3 p orbitals, each of equivalent energy, and each perpendicular to the other two. Sets of 3 p orbitals are commonly represented with one on the x-axis, the second on the y-axis, and the third on the z-axis, hence their designations. P underscore x, P underscore y, and P underscore z. Oh, let's see. Preheat oven to 350. B. Electron configuration of atoms. The electron configuration of an atom is a description of the orbitals and its electron. The electron configuration of an atom is a description of the orbitals its electrons occupy. Its electron occupies. No. Okay. The electron configuration of an atom is a description of the orbitals its electron occupy. Every atom has a number of possible electron configurations. At this stage, we are concerned only with the ground state electron configuration. The electron configuration of lowest energy. We determine the ground state electron configuration of any atom by using the following 3 rules. Rule number 1, orbitals fill in order of increasing energy, from lowest to highest. Example, in this course, we are concerned primarily with elements of the first, second, and third rows of the periodic table. Orbitals in these elements fill in the order 1, 2, 3, 4, 1s, 2s, 2p, 3s, 3p, 4s. Rule 2, each orbital can hold up to 2 electrons. Example, with 2 electrons, a 1s orbital is filled with and is written 1s squared. With an additional 6 electrons, a set of 3 p orbitals is filled and is written 2px to the squared, 2py to the squared, 2pz to the square. Alternatively, a filled set of 2p orbitals may be written 2p to the 6. Rule 3, when orbitals of equivalent energy are available but there are not enough electrons to fill them completely, the one electron is added to each equivalent orbital before a second electron is added to any one of them. Example, after the 1s and 2s orbitals are filled with 4 electrons, a 5th electron is added to the 2px orbital, a 6th electron to the 2p orbital, and a 7th electron to the 2p2 orbital. Only after each 2p orbital contains 1 electron is a second electron added to the 2p_x orbital. For 10 electrons, the ground state electron configuration is 1s to the squared, 2s to the squared, 2p to the x squared, 2p to the y squared, 2p to the z squared, or alternatively, 1s squared, 2s squared, and 2p squared. Gonna be yummy. What's this? Caramel filling contains milk. Oh. I'm not fasting today, so. Step 2, mix, or brownie mix. Egg. 1 large egg. This is my punishment for throwing eggs. Oh, two times. I did it twice. Look out. I'm gonna eat. Okay, next, brownie mix, egg, melted butter. 1/2 cup of melted butter. Let's see. Melted butter, it's gonna curdle. This is steamy. Alright, let's find out. Yum. Tablespoons. Oh! Oh! Where does it go? Alright, 1. 218th. 3. Stir together in a large bowl until well blended, about 50 strokes. Alright, Lewis structures. When discussing the physical and chemical properties of an element, chemists often focus on the outer shell of its atoms because electrons in these shells are the ones involved in the formation of chemical bonds and in chemical reactions. Outer shell electrons are called valence electrons, and the energy level in which they are found is called the valence shell. To show the electrons of the outer shell of an atom, we commonly use a representation called a Lewis structure, after the American chemist Gilbert N. Lewis, 1875 to 1946, who devised this notation. A Lewis structure shows the symbol of the element surrounded by a number of dots equal to the number of electrons in the outer shell of its atoms. The atomic symbol represents the nucleus and all filled inner shells. Wow. The noble gases helium, neon, and argon have filled valence shells. The valence shell of helium is filled with 2 electrons. The valence shells of neon and argon are filled with 8 electrons. The valence shells of all other elements shown, there's a table, contain fewer than 8 electrons. Alright, 50 strokes. Do. Yeah. It's lumpy. Spread into a grease pan. What is this, brownies? Brownies. Alright. Spread. Now we are spreading. There was a lot of steps in between 2 and 3. Right? What does it say? Well blended, about 50 strokes, then spread into a grease pan. We haven't even got step 3 yet. Damn. Anywho, Lewis' model of bonding, formation of ions. In 1916, Lewis devised a beautifully simple model that unified many of the observations about chemical bonding and reactions of the elements. He pointed out that the chemical inertness of the noble gases indicates a high degree of stability of the electron configurations of these elements. Helium with a valence shell of 2 electrons, neon with a valence shell of 8 electrons, 2s to the square 2p to the 6, and argon with a valence shell of 8 electrons. The tendency of atoms to react in ways that achieve an outer shell of 8 valence electrons is partially common among elements of the groups Roman numeral 1A. Okay. What? Groups. Okay. V 1A 2 5 7A. Okay, groups 1 to 7. The main group elements, and is given the special name octet rule. Alright. Octet. Okay, bake on rack in the center of an oven following the, okay, this is an 8x8 pan, so 32 minutes. This is thick. This is a rack. Why don't you need a rack on rack? It's on a rack. You need another rack? Ruined my rack that I already have.